Section 3.3, our first derivative test. The first derivative test is going to allow us to find the increasing and decreasing intervals of a function. What do we need to get out of the first derivative test? Well, to start with, if we know that the first derivative is greater than 0 on, or for all x values on interval a to b, then f is going to be an increasing on that interval. If it's less than 0, it's going to be decreasing. So if we think about a graph here, maybe a nice little cubic, like the cubics there, we've talked about the extrema and how to find those critical values. We're looking at the critical values again. We're going to be looking for those horizontal tangent lines because we're going to see that those increasing and decreasing intervals are going to change across those critical values. So notice to the left of this point, we have positive slopes. If we were to draw in some of the slopes in there, we'd have positive slopes. From this point, let's call it maybe A and let's call it B. Then we would have negative slopes down to B. And then from B over, we would have, again, positive slopes. Where we have f prime of x equal to 0, then we're going to see that f is constant, or that we see that there is no increasing or decreasing value. So we say that a and b were not increasing or decreasing at those points. So the steps that we're going to take to be able to find this increasing and decreasing intervals: one, we're going to find all the critical points, which we've done in the past. We set the derivative equal to 0, where it's also undefined or non-differentiable. We're going to identify the intervals about the critical points. We're going to find test values. I've kind of added that in there. Find test values on the interval. And then we're going to determine the sign of f prime of x. If it's positive, it's going to be increasing. If it's negative, it's going to be decreasing. When we determine the signs of f prime, we're actually looking at the slope of those test values. So we know, or we're going to see, that on this interval, from negative infinity to a, all of these slopes are going to be positive. So it doesn't matter what value we pick in this region from negative infinity to a, it's always going to be a positive slope. From a to b, we're going to always see a negative slope, and b to infinity, we're going to see a positive slope. So that's what we're looking for: critical values, a and b, and then finding some test values in that region. So let's go ahead and get started. Oh, our first derivative test, I guess, as well, we should talk about. If f prime of x changes from positive to negative at a critical point, then f of x has a relative maximum at that point. If it changes from negative to positive, then it has a relative minimum. So that's going to be important to us as well, especially as we get into what the graphs look like and what the first derivative tells us about the original function. So let's go ahead and start by finding the relative extrema of a given function. So we're going to give you f of x equals 3x to the fourth minus 4x to the third minus 12x squared plus 5. First thing we're going to do is go ahead and find our first derivative. So that gives us 12x to the third minus 12x squared minus 24x. We're going to go ahead and set that equal to 0. We're going to factor out of 12x. So we're going to end up with x squared minus x minus 2 equal to 0. We can go ahead and factor that x squared minus x minus 2 into x minus 2 and then x plus 1. Set that equal to 0. So x is going to equal 0, 2, and negative 1. So these are my critical values. What I'm interested in is setting up intervals about these points. My lowest possible point that I can have, x value, and label it intervals. We start at negative infinity, and we're going to come up to our first critical value that we get to, our first critical number, which will be negative 1. Then we're going to go negative 1 to our next critical value, which would be 0, and then 0 to our next critical value. And we're going to continue this until we get to infinity. 2 is our last critical number that we had there, so we go to infinity. Now what I want to do is go ahead and find my test values. I want a number that's between negative infinity and negative 1. No reason to go to negative 1,000, negative 10,000. Keep it relatively nice and clean to work with. Negative 2 works. Between negative 1 and 0, negative 1/2 will work. Between 0 and 2, 1 will work. and between 2 and infinity, 3 will work. So those are the test values, and those are the values that we're going to plug in to our first derivative. So we're looking for the sine of f prime of x. That's our first derivative test. And what I would suggest that you do, you can, if you have a calculator, or if it's non-calculator, doesn't matter. What we're interested in, if you have a calculator, you can put it into your table. But I would suggest that you do this without a calculator, I guess, just to make sure you can do it for a multiple choice test or quiz without a calculator. So what I'm going to do is take -2 and I'm going to plug it in for all my x's. And I'm only interested in the sign. So I know -2 times 12. I don't care if it's -24. I just know that it's a negative value. If I plug in -2 into my second one, -2 minus 2, that also gives me a negative. And -2 plus 1 is going to give me a negative. So a negative times a negative times a negative gives me a negative. If I plug in -1/2, the first one's still going to be negative. -1/2 here, -1/2 minus 2, that's going to be a negative. And -1/2 plus 1 gives me a positive. So negative times a negative times a positive is going to be a positive. If I plug in 1, I have 12 times 1, which gives me a positive. 1 minus 2 gives me a negative, and 1 plus 1 gives me a positive. So when I multiply these together, it's going to be a negative. If I plug in 3, I get a positive, and another positive, which gives me positive. So I know I have negative, positive, negative, positive. What does that tell me about my function? Well, I know I am decreasing on this interval, I'm increasing on this interval, I am decreasing, and then I am increasing. Furthermore, from the first derivative test, I know if I go from decreasing to increasing, so my graph, I know I go from decreasing to increasing, I know I'm going to have a relative minimum. And I know that that's going to occur at -1 something. My increasing to decreasing, again, if I go from increasing to decreasing, I'm going to go up and I'm coming back down. So I have a relative maximum. And again, that point's going to be occurring between these two intervals, so between -1 and 0 and 0 and 2, is going to occur when x equals 0. And finally, I go from decreasing to increasing, I have another relative minimum. And that point is going to be between these two intervals, between 0, 2, and 2, infinity, is going to be the number 2. So what I can do from here is go ahead and plug these values in for my x into the original function. So I plug in -1, I'm going to get 3, plug in my -1 there, I'm going to get a +4. -1, I'm going to have a -12, and then +5. So I get 3, 4, gives me 7, and 5 is 12, minus 12 gives me 0. If I plug in 0, oh, nice easy one there, huh? We get 5. If I plug in 2, I get 3 times 16, minus 4 times 8, minus 12 times 4, minus 48, plus my 5. So I get 48 minus 32 minus 48. Oh, isn't that nice? So 48's cancel, so I get a -27 as my answer there. So that gives you an idea of where we're going to see our increasing and decreasing intervals and that first derivative test. So I know my relative maxes and my relative minimums. So we're going to get nice trig function here. Ooh, your favorite trig. It comes back, doesn't it? So I'm going to find the relative extrema on the interval 0 to 2 pi of x minus 2 sines of x. So our first derivative is going to be 1 minus 2. Derivative sign is cosine of x. So I can go ahead and set that equal to 0, I guess. I don't need to do that again. So I get the cosine of x equal to 1/2. So my question is, where does the cosine of x equal to 1/2? If you need to, come out here and draw in your unit circle. We know that cosine is the x value, and the sine is the y value. So we're coming over a little and up a lot, if you remember that saying from me. So if we come over a little and up a lot, that makes a pi over 3 angle. So I get pi over 3 as my x value. We're from 0 to 2 pi, So we also know that we can come around here, and we're looking for the cosine, so we're going to come down. Remember, this was 2 pi. If we subtract pi over 3 off of that, we end up with 5 pi over 3. So those are the two values that we're going to be interested in. So we're going to go ahead and test on our intervals. We're going to go from negative infinity to pi over 3, pi over 3 to 5 pi over 3, and then 5 pi over 3. Oh, actually, we don't need to go to negative infinity, do we? We can go 0. Since we're on the interval 0 to 2 pi, we don't need to go to negative infinity. And then 5 pi over 3, we can go ahead and go to 2 pi. So we're looking for some numbers, some test values on this interval from 0 to pi over 3. I would suggest that we do some nice, clean, easy numbers maybe. So pi over 4 kind of makes sense to me. Coming over here, we can do pi. We can do pi over 2 if you want. So we can do pi there. And then over here, we can do 7 pi over 4. And that's going to give us that value, that test value. So we're looking for the value, the sine of pi over 4 pi and 7 pi over 4. When we plug it into 1 minus the cosine of x. When I plug in pi over 4, I know the cosine of pi over 4 is the square root of 2 over 2. So I get 1 minus 2 square root of 2 over 2. Is that value going to be larger than 1 or less than 1 is basically what I've got to ask myself. Oh, I guess you should see it there, huh? So I get 1 minus the square root of 2. Remember, the square root of 2 is a little more than 1. So 1 minus something that's larger than 1 is going to give us a negative value. If I plug in pi, I get 1 minus 2. Cosine of pi is negative 1. So I get 1 minus 2 times a negative 1, which gives us a positive value. And then 7 pi over 4. We can go ahead and plug that in. The cosine, again, of this value is going to be negative. So we're going to have a negative value, or 1 minus, it's going to be a positive value, sorry. And 1 minus 2 times that is going to give us a negative value. So we have a decreasing interval, an increasing interval, and then a decreasing interval. Again, if it's negative, it's decreasing. Positive, it's increasing. Likewise, from decreasing to increasing, if I go decreasing to increasing, I know I have a relative minimum. Increasing to decreasing, I'm going to have a relative maximum. I can also go and find those values. Again, pi over 3, and my relative max is going to occur at 5 pi over 3. So I'm not going to go ahead and find those y values, but to find those y values, you'd plug them back in to the original function to get that value out. Last example here, we're going to do sine to the fourth x plus cosine of x to the fourth on the interval from 0 to pi. So our first derivative test, we're going to find the derivative. We have 4. We have the sine of x, cosine of x. This is to the third. Recall that we can write this as sine of x to the fourth power. So we have a chain rule. To that, we're going to add 4 cosines to the third x, and then times derivative of the cosine, which is negative sine of x. So what happens? Well, we can go ahead and factor out a 4. Looks like a sine of x and a cosine of x is going to be in common for both of them. So if we look at that, we have sine squared there, and then minus a cosine squared x. Oh, so close to being a nice clean number, isn't it? Oh well. So we have sine squared minus our cosine squared. So we're going to set each of those parts equal to 0. The 4 doesn't matter, but the sine of x is going to equal 0. The cosine of x is going to equal 0. And then we also want sine squared to equal cosine squared of x. So if we think from 0 to pi, the sine of x is going to equal 0 at 0. The cosine of x is going to equal 0, and at pi, I guess. We have that as our endpoints. Cosine of x is going to equal 0 on pi over 2. And then where does the sine of x squared equal the cosine of x squared? Well, they're equal. Sine of x equals the cosine of x on our 45s. So our pi over 4 and 3 pi over 4. So we're looking at x equals 3 pi over 4 and pi over 4. So my intervals that I'm working with are going to be from 0, we'll call them ints, 0 to our next value, which is going to be pi over 4, pi over 4 to pi over 2, pi over 2 to 3 pi over 4, and then 3 pi over 4 to pi. So now we need a value that's between 0 and pi over 4. So those are going to be our test values. And that's going to give us pi over 6. From pi over 4 to pi over 2, we can do pi over 3. From pi over 2 to 3 pi over 4, we can do 2 pi over 3. And then 3 pi over 4 to pi would be 5 pi over 6. And then we're looking for the sine of f prime of x. So I'm going to plug my pi over 6 in up here. So the sine of pi over 6, that's going to give us a positive. Cosine of pi over 6 is going to be positive as well. But what's about sine squared minus cosine squared? So that's really going to determine what the value of this is. So if we take pi over 6 and plug it in, the sine of pi over 6, we're coming over a lot and up a little, so that's going to be our 1/2 squared minus radical 3 over 2 squared. So we know that radical 3 over 2 is going to be larger than 1/2, so we're going to get a negative value there. At pi over 3, we're going to look at our sine as being radical 3 over 2, and our cosine being 1/2, so that's going to give us a positive value. Now when we come over to 2 pi over 3, what do we know about 2 pi over 3 over here? Well, here our cosine is going to be negative. So our x is equal negative there, our y's or our sines are going to be positive. So here we have a negative value times a positive. So we get a negative from the first part of it. So our sine and our cosine are going to be flip-flopped there. So if I take the sine of sine squared of x, that's going to be my radical 3 over 2 minus my 1/2 squared. So that's going to give us a negative value. And if I take 5 pi over 6, plugging that in again, since there's flip-flop, I'm going to get a positive value. So I go from decreasing to increasing to decreasing back to increasing. So I have a relative minimum. So I go from negative to positive. Positive to negative, I have a relative max. And from negative to positive, I have a relative minimum. And I can go ahead and find those values. Again, my interval or my value that's in between these two intervals is pi over 4. My interval here is between pi over 2, for my x value, and this one's going to be 3 pi over 4. Again, you can go ahead and find those values by plugging them into the original function to get what the y value is of that relative max and relative min. I know it's been kind of a lengthy one, but it gives you an idea of where we find our first derivative test and why it's useful being able to find our increasing and decreasing intervals. Good luck and have fun finding those derivatives and increasing and decreasing intervals.